Thanks for your patience there. You guys are okay? What we'll do now is I'll save some of the administrative announcement stuff for after the first talk. Right now I want to introduce Denis Boas, currently working for Terraces Networks for quite a few years for the NSA. Everything else is classified. We'll let him tell you about it. Come on, Denis.
Sure. Great. Well, thanks for showing up this morning, folks. So my name's Denis Boas. I currently work for Terraces. I started working on computer networking in 1971. It was the ARPANET, running BBNN 1822 protocols, and we had 12 IMPs, intermediate message processors, the predecessors of the routers, connected to a blindingly fast 9.6 token passing network. And we measured our users in hundreds, and our primary application was Telnet. It's been an interesting ride, to say the least. I worked for 12 years for a National Security Agency and Army Security Agency. I spent some time with Digital Equipment Corporation, went to a little company called Wellfleet, which became Bay Networks, which became Nortel. I didn't actually move. I kept my same office. The name on the top of my paycheck kept changing, but nothing else actually changed. Decided, hey, I want to go back to a startup. Went to a little company called Zedia, 50 people. Promptly got bought by Lucent, proving I had no timing whatsoever. And ended up about 7 years ago at Terraces. So my background is primarily security, although I've been a network manager, I've been a forensics analyst. I think I've actually held every job in computer networking you can hold. I was a DNS namespace administrator for a while. It's not something I recommend if you don't enjoy migraine headaches. So currently, I am the director for our security solutions at Terraces, with responsibility to make sure that our security products actually communicate with each other and form some type of coherent solution. I promise you I'm not going to talk about our products. One of my very favorite quotes is by Vint Cerf. Everybody recognize the name? Vint Cerf, not Al Gore, but Vint Cerf probably was responsible more than any other individual for creating the internet. He was one of 3 people who wrote the primary protocols and architectures. And one of his comments was that the wonderful thing about the internet is that you're connected to everybody else. The terrible thing about the internet is that you're connected to everybody else. And that literally is the problem and the challenge of security. The network connects us to all the resources that we absolutely need. It also connects us to every college student in the world. It connects us to a very thriving identity theft group in Soviet Georgia. And of course, all of the botnets that are roaming around out there and being put up for sale. By the way, what does a botnet do? You know, a botnet controls computers. Well, you can go to exchanges in Soviet Georgia and buy time on a botnet. You ask for, so you need so many computers and you need so much time, and they'll give you the command channel for them for that period of time, and you can do with them as you like. Identity theft. Everybody know what the going price for a clean credit card number is on the exchanges today? 75 cents. 75 cents for your clean credit card number. People buy them by the thousands. So, when we first connected to the internet, everyone looked at the internet and went, wow, we got to build firewalls and DMZs. We got to protect ourselves from the internet. And then we found out that actually most data theft, it didn't come across the firewall. Most data compromises came from the access layer of the network. Something around 80% of all data loss actually comes from inside the network. So the entire concept of a trusted network, the green network, doesn't really exist anymore. You can cause a major argument at most security conferences by simply asking, where are the threats? Are they internet-based or access layer-based? I want to propose that it doesn't really matter. What they're talking about is, where do you get infected? So I take my laptop home. And connect to the network, get it infected, take it to work, plug it in. The attack is launched from the access layer of the enterprise network, right? I got infected on the internet, but the attack is actually launched. Look at Conflicker. Nobody got infected by Conflicker, not really. On the primary infection points were infected web servers, right? The secondary point was they plugged them into the enterprise network and it spread that way. So what we find is that the attacks are actually launched from the access layer. All the mobile computing devices. I liked it better when a portable computer was roughly the size of this podium. People didn't move them. They left them plugged into the port that I put them on, and they stayed behind my firewall, right? And I actually remember the time when they were that big. Now we've got these silly things, and iPads, and we have all the portable devices, and we have wireless networks, which completely warp the idea of where the access edge even is. So the idea of trusted and untrusted doesn't really exist today. Most security people today will tell you there is no such thing as the trusted network. There's the enterprise network, the interior network, but I'm not sure I can say it's trusted anymore because it's vulnerable in too many ways. So your trusted network, your access edge, your wireless edge, your critical servers. This is your enterprise network. We're going to talk about hardening that access edge. We're going to talk about three components. Control. Ideally, you want to enforce least privilege. Everybody know what least privilege is, right? Give somebody access to the information they need to do their jobs and nothing more. There's a fundamental difference between what someone needs to do their jobs and what they think they need. So what they need and what they want are two radically different things. I did find a way to get somebody to give up some of their privileges once. When I was in Germany, I was responsible as top secret custodian for a set of systems. And when I went in, I realized that my boss was a light colonel, and he had the root passwords. He had demanded that he have the root passwords on all these systems. He didn't need them, but he was a colonel, so he could have them. So I sent him an email, or I actually didn't send him an email. I made the comment to somebody that I knew would get the comment back to him that I was actually pleased that he had those passwords, because if we ever had a serious data breach, I'd have somebody to talk to on the way to the brig. Because the military is more about a wide brush when it comes to dealing with security flaws. I know it got back to him because about a week later I got an email from him asking me to change the root passwords, and he probably really didn't need them. Fear is a wonderful thing. You want to enforce least privilege acceptable use as near to the access edge as you can. Visibility. Can you answer the question, do you know which users are using which applications to access what resources and how much bandwidth they're using? Simple question, right? Do you have that level of visibility into your network? It's nice to have that level of visibility into your network. It's nice to be able to tell an auditor that, yes, I know who is accessing the cardholder data environment. Right? Do you even, I'll go even better. So this is a question that I always used to love getting asked. Could you tell me all of the mail servers connected to the network? can give you a list of the ones that are supposed to be connected to the network. I'm relatively sure that if I really scan the network, I'm going to find out that it's wrong. I can't even tell you how many internet connections I have to some group out in Cleveland bought their own and plugged into it. And then we don't actually have any idea at corporate about that. How many servers, pick the server, connected to your network? Can you give me an inventory of all of the end systems connected to your network and what OSs they're running and what ports they're connected to? Visibility. The more the better. Response, the ability to recognize a threat and respond to it. The response needs to be as automatic as possible. Things propagate way too fast, and hackers, just people attacking the network, and I'll use the term hackers in its pejorative terminology as opposed to what we think of ourselves as, because the rest of the world doesn't think about us as good guys. They, amazingly enough, don't want to attack at 9 o'clock in the morning when the A-team is in the Security Operations Center. They tend to do it at 3 o'clock in the morning when, if anybody is in the Operations Center, they're probably asleep. And consequently, we're going to have to wait till 8 o'clock to deal with a problem that's now been going on for a couple of hours. Not a good idea. What we also have to do is, if it's coming from the access layer, we need to remove the attacker from the network. If we just stop the attack and leave the attacker connected, that's just not a good idea. They're just going to find another way around, right? That's a problem with the traditional IPS. You stop the attack, but the attacker is still connected. That's a little bit like, you hear something in the living room, you go down, someone's carrying your TV out the front door, and you go, no, go put that back. And they go, okay, I'll put it back, and you go back upstairs and go back to bed. Probably not really an optimal situation. Control, least privilege, we know about that. And how do we traditionally have we dealt with least privilege? We've used password controls, right? Access lists on computers, password controls, to make sure that only HR people can log into the HR systems and only finance people can log into the finance systems. What's the problem with that? Aside from the fact that people pick rotten passwords, let's just accept the fact that, when it comes up and it says, give me a new you got to get a new password, and you go, that's A12, it was A11 last week, so it's A12 now. That's not a good way to pick a new password. Also, of course, none of you would use the same password for all of your accounts, right? OSs are vulnerable. Always going to be, always have been. There are a few OSs that are reasonably well hardened, but they're not commercially available. They're very well within the endbinds of the security groups. Commercially available operating systems are made to be user-friendly, do a lot of things. The more sophisticated something is, the more vulnerable it is. The more features it has, the more vulnerable it is. The more usable it is, the more vulnerable it is. Operating systems are going in that direction. That takes them diametrically opposed to security. Why do we constantly find new flaws in operating systems? Right? In all this time, they should have been getting more secure, and they're not getting more secure. So let's accept the fact that OSs are always going to be vulnerable, and we need seriously to think about moving our control point out to the edge of the network. You can't really compromise a server if you can't send packets to it. I can't do anything about a user who has a legitimate access to a machine and chooses to misuse that data. That's actually not a security issue as much as a management issue, right? I'm an HR person. I have access to the HR data. I steal HR data. Okay? Network security can't solve that problem for you. What it can solve is, I'm on the loading dock, and I just hacked into the HR server. That should never happen. That is a network security issue. So if we move the controls out to the edge of the network, we can prevent or make it more difficult for people to access things they shouldn't access. Let's just start with a basic idea. On the access edge of the network, end systems should not be servers. There's no earthly reason that someone plugging into the access edge of the network should be able to become the DHCP server. They shouldn't be running a mail server. They shouldn't be running SNMP. They shouldn't be running ICMP. Right? Those are not user end system functions. Any of those packets should basically be dropped at the ingress port to the network. That will immediately solve a lot of problems. It will also immediately free up a lot of wasted bandwidth. Servers should not be acting as end systems. Hannaford Supermarkets suffered a major loss, and it was one of the first data in transit losses that we'd seen. Basically, there were a series of stores, and the server in the store that handled the credit card information had a Trojan put on it. What this system was supposed to do is read the credit card information, send it to an internal server. That internal server would then clear it with the credit card clearinghouse. It did that. What it also did is took the banned information and emailed it to an address in the Soviet Union. That was an unintended feature. The point is, it should have never happened. We could have put port level controls on that that said, this server should only be talking to this one internal server. Any attempt to go to another address should have been dropped. It should have never been originating an email message. Servers don't originate email messages. FTP servers don't initiate connection, right? Servers shouldn't act like end systems. End systems shouldn't act like servers. Just basic controls like that go a long way from eliminating a lot of the problems without even getting into implementing 802.1x and role-based authentication. So what we're looking to do is harden that edge of the network. Resource containment basically means at the edge, you authenticated, 802.1x authentication, I'm an engineer, I authenticate as an engineer, I get access to engineering resources. If I try to send packets to a server that my boss, who's a manager, has access to, they're just going to be dropped. They're not going anywhere. You can tie in with that and tie in with it the idea of protocol, socket level controls. So, okay, I can talk to this server, but you have to use an authenticated protocol. It has to be HTTPS. You can send packets to the VoIP server, but they better be a protocol the VoIP server needs. It better not be FTP. It better not be Telnet. Right? So again, combining the idea of resource and address to give a socket level control. And finally, it gives me the ability to do bandwidth controls. I'm an engineer, I get big pipes for FTP. My voice channel, rate limited. Because voice needs high priority, but it doesn't need high bandwidth. And the idea of a prioritized, unbandwidth limited protocol roaming around your network is an invitation for a denial of service attack, isn't it? Right? So give voice the bandwidth it needs, but rate limited. Prioritize it, rate limited. Done where? At the connection point to the network. So hardening a server. The beauty of hardening the server at the port, if I let's assume that you can harden a Windows server. You harden it by turning off things, right? But if you lose administrator, they're just going to turn them back on, which is what happened in the Hannaford hack. So don't harden it there. Make the final hardening at the port level. That's out of the reach of anybody who's hacked into the server. Static things, you got printers connected to the network, right? Fine, there ought to be a printer control access. So that if someone unplugs the printer and plugs their laptop into it, they don't get unauthenticated access. They get printer access, which will be very depressing. The other idea is, and administrators are going to hate me for saying this, nobody gets all access. Even a network administrator doesn't need access, unlimited access to everything. Right? In the NOC, you can have a port that's wide open, no controls on it, put it in the NOC behind a locked door, paint it red so if somebody plugs into it, you know they're plugged into it, and if the whole world's coming to an end, plug into those ports, and the NOC personnel now have unauthenticated access to everything. But if you're a network administrator roaming around with your laptop, fixing problems, you need some access, but you don't necessarily need all access. Sorry. And depending on the security level of the organization, you're not going to get all access. .802.1x is still a good way to authenticate users, gives me role-based access control. NIST has clearly come out and said that, role-based is what we need to do. All of the compliance mandates are mandating role-based access control. Machine control can be done with certificates. If your threat tolerance is low, that is, if your threat profile is you're protecting something very critical and you're protecting it from industrial espionage attacks, maybe you consider biometrics. Biometrics work. When I go through Heathrow, I don't actually talk to passport control. There's a line that has a big eyeball on it, and my iris patterns are on record with the airport. So I go up, look in a box, it says move your head this way, and you center it around your eyes, and they turn green, and it says, welcome back, Mr. Boas, and it prints out something that I put in my passport, and I go on through. King Fahd Airport in Saudi Arabia, everybody gets iris scans to get in and out. They work. An iris scan is something like 700,000 to 70,000 times more accurate or more unique than a fingerprint. And no, contrary to James Bond, you can't pop out somebody's eyeball and put it up to the scan.
Have you tried to do it real-world test yourself yet, though?
It won't work. The scan runs it flashes a very high frequency light that the eye recognizes, and the eye has to contract. So you can't use a high-res photograph, and you can't use a film because it's got to react within microseconds of the pulse. So it has to be actually a living eye. It works. Again, it depends. What are you trying to protect, right? Everyone has a different fault tolerance or threat tolerance. Network access control. Network access control adds another layer. It helps me answer the questions, who is connected and where are they? Just because because you authenticate into the network doesn't mean I'm going to give you full access. Let's go to a college environment. Cool. I authenticated as a professor. Great. I did it from student housing at midnight. There's only a couple of things that can be happening here, okay? No way am I getting faculty access. I authenticated as the CFO. I'm going after the cardholder data environment. I'm doing it from an SSID. No, not so much. Had TJX actually had that in place, they wouldn't be facing all the fines they are, because their initial hack was from a parking lot in Florida across a wide open wireless network. So NAC should be able to add not only who you are, but where you are, what time of day is it, how did you authenticate? You authenticated 802.1x, I trust you more than if you MAC authenticated. Right? We're adding layers of protection into this system. Visibility. Visibility represents network behavioral anomaly detection. Baseline. What does your network look like? What is normal? Or at least what passes as normal in any network. What applications should not be running? One of the questions, again, I don't know if you've ever had to deal with an auditor for like PCI, one of the questions they're real interested in is which users are using which applications to access the cardholder data environment, and prove to me that they are required, that they are valid, right? Well, first you got to figure out what they are, so that's the initial problem, right? So you need flow-level views of the network. You need to be able to detect threat flows, flows that don't make any sense, long-duration unidirectional flows, ICMP streams where you've got more replies than you've got requests. Wonderful. That's a back channel, right? That's a P-channel attack. You've got a Trojan. It's using ICMP replies to pass back information. Zero payload long-durational flows. Not a good thing at all, right? So there are certain flows that we just recognize as threat packet, as threat signature. You've got a server. Never in its life has it initiated a connection. Last hour, it initiated 100,000 outbound connections. Guess what? You don't own that server anymore. Someone else does. IPSs, IDS and IPS, looking for signature-based and protocol-based attacks, right? Things that don't follow this protocol. Oh, look, it's a VoIP packet. Oh, look, it doesn't have the required elements. It says it's a VoIP packet. It's not, right? Protocol violation. Here's a TCP packet. All the flags are set. No, not quite. TCP packets don't have all the flags set. It's a Christmas tree attack, right? Illegal protocol combination. Pattern matching. You know about the pattern matching signature. Host HIDs. HIDs generally, when we talk about these, are for servers, not end systems, right? On your server. Be nice to know that your engineering server just had 4 interfaces that dropped into promiscuous mode. Sorry, that shouldn't happen. You just lost the server. You don't own it anymore. It's being used to scan your network. MD5 integrity checks. The exe host file just changed and you didn't do it. Not such a good thing. The log file just got shorter. Really not such a good thing. Log files don't get truncated unless someone is erasing what they've done. Really not a good thing. You should know about that. File ownership, inode, dates, all these things that are footprints on files that should not be changing. A HIDS will tell you if you still own that server. And believe me, folks, the idea that one should never take a server offline because people will lose access to the data, you know what? If you don't own it, take it offline. Because the data on it is already in question and probably corrupt, and all you're doing is propagating bad data. I don't care if it's a denial of service attack. It's a denial of service attack against something that you can't trust. And a SIM to put it all together is real nice because the problem when you build out these solutions isn't that you don't have enough information, it's that you have so much information that trying to reduce it to actionable offenses, that's what a SIM does for a living. A SIM looks at, here's all the events coming out, here's all the flow data, here's all the vulnerability data, puts that together and goes, yes, these 150 things, treat that as one offense. That's called data reduction rate. The SIM that we ran at Interop, we were getting a data reduction rate of 800,000 to 1. Now that is absolutely something you would never see in a real environment. But we had so much attack traffic compared to real traffic that I just have screenshots of that because I'll never see that kind of a number again. We ran that at Interop's request without firewalls. They said, we want to run this without firewalls. And we ran it basically with port level controls on each booth and no overall firewall. I would never recommend it, but it was a great exercise. So IDSs, an IDS on either side of a firewall is a very cool thing. The delta shows you if your firewall rules are working. Have you ever misconfigured a firewall? It's real easy to configure a firewall and have it do something really bizarre that you didn't expect. Putting an IDS tap on either side of it, look at the difference, and you can prove to an auditor it actually works. Behavioral sensors probably in the routing core. Distribution layer, HIDS on critical servers. IPS is probably in front of critical server farms. You can't afford to put IPSs everywhere, so you put IPSs in front of critical servers, and you put the IDS to cover the larger area of the network. The amount of animation in a slide is directly proportional to the length of the plane ride getting to the event. I've had these slides for a while, so each plane trip I add a little bit of animation to them. Basically, the goal of response should be to stop the attack and to remove the attacker's ability to continue the attack. The easiest way to do that is to quarantine them at the access point. Whether you quarantine them by IP address, by MAC address, by user, however you can do it, you need to get them off the network. Again, it's a judgment call. Somebody's doing a low-level scan of your network. Do you want to remove them? Don't know. What are you protecting? Is this college? Is it high tech? Is it biotech? Is it the Pentagon? Right? All of this is to implement your security policy. Everyone has a security policy, right? We've all read your security policy and understood that. I worked for NSA. We had a security policy. I know we did. It was 8 volumes. It sat on the shelf. And volume 4 was the most valuable to me. because the desk leg, desk leg was a little bit shorter than the other one. If I took volume 4 and put it under that one leg, it leveled out my desk very, very nicely. A security policy ought to be understandable and not so overwhelming that no one will use it. The point is, this is to implement your security policy, and what dictates your security policy? What am I trying to protect, and who am I trying to protect it from? If you're LL Beam, you're not going to be the target of state-sponsored industrial espionage. The sporting goods industry is not the hotbed of industrial espionage. If you're a cutting-edge biotech company, that may not be the same. If you're a cutting-edge biotech company, it's cheaper to steal that research than it is do that research. You are targeted by state-sponsored industrial espionage. At the end of the war, all those intelligence agencies didn't go away. They turned from military intelligence to economic intelligence. They still exist. So whether or not you want to do this and for what depends on your threat profile. By tying pieces together, you're going to like this. So by tying together NAC and the IDS, we detected the fact this person did a scan or violated our network. We quarantined them. We informed NAC this person's quarantined. They unplugged and moved to another port, and they didn't even authenticate because NAC remembers they're blacklisted. So they don't get another shot at the network. So you're building out layers of protection. And to get to my critical server, you have to get through the acceptable use policy. 802.1x dictates what you can access. You have to beat that. You have to get by NAC, which knows where you are and what time it is, and adds that level of protection. NAC also can be set up to scan your system and download an agent onto the system to make sure that the applications you're running are within our security policy. You have to avoid the IDS, you have to get through the IPS, and you have to somehow evade the hits. Oh, by the way, at the end of that, you have to guess the right, you have to run. After you do all that, then you can run your hack against the operating system weaknesses. The operating system controls become the final line of defense, not the only line of defense.
Can I just hire Keith to come in and steal the box for me?
Yep, come and steal the box. If you don't have physical control, you can have it. By the way, that's an interesting point. We're talking about cloud computing. Everyone knows about cloud computing, right? Really, really cool. How do you know where your data is being stored? Being stored in the cloud, right? Well, where are the servers? China?
Yes, we provided.
You just know that the servers are going to end up the cheapest place they can put them, which is going to be Malaysia or China or someplace like that, right? So how protected is your data? If the Chinese government shows up and says, give me the data, do you think they're going to say, oh no, I'm sorry, you can't have it. The U.S. says, not so much, right? There is a huge questions being asked legally as to how are you going to deal with it. It's your data. The fact that you put it on the cloud does not remove your responsibility. If it gets compromised, you get sued first and then you get to sue the cloud provider. Maybe. How are you going to deal with a PCI audit if your data is on the cloud? PCI audits are about accountability, right? The cloud is about something entirely different. So the Cloud Computing Security Forum is looking at dealing with this. The government is looking at dealing with it in terms of financial, for banking and things like that. How are we going to deal with this as we start to move more and more stuff into the cloud? There are all kinds of interesting issues involved. So let me wrap it up by showing you a security framework. In any network, we have different types of data. We have flow data, net flow data, we have event data, we have location, identity, and vulnerability data, right? In networks, we have flow sensors, switches, IPS and firewalls, wireless management, wireless IPS, NAC. We have a SIM, we have unified communications, that's your VoIP environment, and I'm going to put something down here in the corner called Security Manager, which is going to tie the pieces together. So flow sensors produce flow data. Switches can produce net flow data and event data. By the way, for a SIM, you want unsampled net flow. Because if you have sampled net flow, you have to start turning off sentries like long duration unidirectional flow. Because if I'm not seeing both sides of the conversation, I can't deal with those. I'm going to false positive. IPS, wireless, NAC, all that information goes to the SIM. That's the piece that makes it usable, that reduces 100,000 firewall events into something that we can deal with. Location data can be fed to unified communications so that when you plug a phone in, the UC system knows where the phone is. Cool. NAC provides triggers to switches saying, okay, this is the dean, he's in his office, it's 12 o'clock, he gets full access. Or this is the dean, it's midnight, and he's in the parking lot. Not so much, gets a different access. NAC can also provide the security manager with information about this person who's been quarantined. The SIM can provide triggers. This person is doing a slow scan of the network. This person is whatever, trying to access the cardholder data environment. This person is a terminated employee who is still on the network. Yeah, that's not so good either, and we see it all the time. Firewalls and IPS can provide triggers. In turn, Security Manager can go back to the wireless system and say, disassociate that user at the access point. Take them off the network at the AP. It can go to NAC and say, blacklist this individual, so if they move, they're still off the network. It can go to the switches and say, let's quarantine. A bunch of security products that don't talk to each other isn't going to give you a solution. A solution requires all of the pieces to integrate into something that works. And that's the problem that we've had traditionally within the security environment is pieces have not integrated well, right? And there's various consortiums and groups that are working real hard to make sure that all the pieces from the different vendors play nice together. Because if they don't, you don't have good solutions. Right? Make sense? So anyway, the suggestion is, and you're going to hear all kinds of things today. I think I'm the only person doing the defend side. Everybody else is going to talk about how to break into things. So rather than try to tell you how to harden an operating system, which is an exercise I believe in futility, I'm just going to suggest that we look at moving the control, the enforcement points, out to the access edge, increasing the visibility, and automating the response. Because all these great hacks that we can run against operating systems won't work if we can't send packets to the operating system. Right? And the nearer the edge you put your enforcement point, the better the protection is going to be. Questions?
What's your definition of edge?
The access, so I'm dealing with the access edge of the network, which would be either the wireless or the hardwired access edge. So I look at it as you have the internet edge, which represents your internet firewall, internet connections. You have your hardwired ports, and you have your wireless ports into your enterprise. So that's the access edge of the network.
Okay. Will you consider also edge?
Pardon me?
Would you also consider edge, let's say, segments between users, so as to also protect
Yes.
against transactions?
Yes. Any of an edge is basically, the edge can be any edge that you plug in users into. It can also be the edge of a security domain. So you may have multiple security domains in your network. The points that those security domains connect also becomes an edge.
Another question, if I may. When you mention NAC, typically where I work with NAC solutions, my experience has been that when I'm working with large customers, if they have a team dedicated to managing the NAC will stay living as a security solution in that network. On smaller clients where they have a jack of all trades that's going to tend to firewall, IPS, IDS, do the server stuff, and then NAC gets removed in a short while. Also, I've seen it, and this is coming from my point of view of administrative oversight.
Sure.
Another point I've seen is where NAC is mainly, at my job, is mainly recommended for any mobile device, anything that goes outside of our network, and we do not apply, or we do not recommend clients to apply to PCs or server networks, where I've seen, let's say, a Cisco rep go in and go like, oh, we'll NAC everywhere. And all of a sudden they have NAC everywhere, and they have a big pain trying to manage all that.
So NAC does a couple of things. NAC will recognize anything connects to the network, NAC will recognize it. So NAC will tell you what's connected, right? NAC also will work with 802.1x to authenticate users onto the network. NAC can be set up to scan systems or download agents to make sure that the system connecting meets security requirements, right? Well, you can deploy NAC, ideally, you can deploy NAC to do any one of those things, and you can deploy it transparently. So when I go in and work with someone on NAC, the first thing I say is, let's just turn on NAC, don't enforce anything, just let it show us everything that's connected. That's completely transparent to the user community. Everyone gets on the network. Nothing's changed, except at the end, I have a list of everything that's connected to my network and where. Right? And the next step would be, okay, so I want to do authentication. So let's turn on authentication, but let's not enforce it. So now show me everybody authenticating onto the network. Show me everybody who failed authentication. Let them on anyway. Let me go fix them, right, one at a time. Now you want to do assessment. We're going to scan them. Turn on assessment. Don't enforce it. Show me everybody who would have failed assessment. Fix them. So by the time you throw the switch and go enforce everything, there are no surprises. Because the fail point for NAC is when you go in over the weekend, you install it, you turn everything on, and Monday morning, 20% of your users can't get on the network. Now, in fact, they shouldn't have because they failed, right? That doesn't solve the problem. Your phone still rang, and they're going to yank NAC out of the environment real quick, right? So staged deployment. Sometimes we've had customers who've done it for compliance, and they just turned on, show me everybody connected to the network. That gave them enough visibility. That's all they wanted. Right? We have the other extreme of university that's using it, along with IDSs that say the first time that a user gets caught running peer-to-peer, they get a pop-up and a warning, you're in violation, accept it. The second time, they get another warning, and the third time, they're taken off the network. Or university, it's one of my favorites, stolen laptops. Somebody reports their laptop stolen. You put it in a stolen laptops group. Next time that appears on the network, you send a message to security. It says, go to this building, this room, and collect the laptop. That one had become so successful that they had a security guard that was really enthusiastic about retrieving the laptops, so much so that the network administrators had an alert sent to them so they could go watch this. It became a spectator sport. So you can, again, you can deploy NAC, and it will do a lot of things. What you have to do is select, what is right in your environment.
Kind of related to what he mentioned, how many people would you say it reasonably takes to effectively make these functions? I know that's a good question, but when you have a full-blown
Sure.
site, whatever deployment,
So I know one university that has everything deployed, and they have everything deployed at university. They have, I don't know, it's a major university, and they have a network. They have the entire network staff, network and security staff in 7 people, and it's a really bad environment where you're churning, 2,500 students. So yeah, it's 80,000 ports or 90,000 ports. Doesn't have to be a lot. Again, it depends on how well it's tuned and set up. There is a learning curve, right? I mean, the whole point of feeding everything to the SIM is to reduce the amount of, I don't need somebody to look at my NAC event. I don't need somebody to just look at these events. Everything comes up to the SIM. I can look at everything from the SIM level. The whole point of a SIM was to reduce the number of people you need. And a lot of it is set up, and once it's set up, it's done, it's static, it's not going to change that much if you design the policy better. So it doesn't have to be a huge. And again, it doesn't matter who does the pieces. The pieces just have to work together. Which is, again, why when you're looking at something like this, you ought to look at it and say, is it standards-based? Because if people are using proprietary anything in there, it means it's not going to play nice for them. TCG, IFMAP, is working real hard. I'm one of those committees. We're working real hard to build out metadata and protocols that allow all these pieces to work together. There is work. There's help coming. Great. Well, thank you very much, folks. I'll be around all day. So if anyone would like to talk or have additional questions, I'll be happy to answer them. I'll be around pretty much all the time. Thank you. Thanks, Ed.